Okay, let's start. My name is Wahid Ahmed, and today we are going to start with our day 2 session regarding SPSS. Most of the people who have joined this session on the last day will be well aware of the content what we are going through. Okay, so there is one request to you. Please turn off your mics. If you have any problem, you can post your messages in the comment section. At the end, we will conclude our session properly, and at the end, the conclusion will be done by the host of this session. So today, basically, we are going to apply some statistical test in the SPSS. Basically, the application applying the statistical test is quite easy comparative to the manual working of the statistical test. So we are going to go through all that interface of the SPSS one by one for the each statistical test that are performed. But I won't be able to represent everything in detail because we have a short time, but we'll try to answer as much queries as much possible. So let's start. Now I'm going to share my presentation with you. So welcome to you all. Is my presentation visible to you all? You can say in that in chat. If yes, okay. So most of the people said yes, they have visible. Yes, there will be the certificate, but you have to fill the form at the end. The session will be concluded by the host. So yeah, let's start without wasting our more time on this. Okay, so let's start with the session. This is the day second. 1 second, just. Okay, let's start with the day 2 session that is about statistical tests and analysis. What we are going to do in this basically workshop, we are going to apply this statistical test in the SPSS. One of them is the t-test, the other is chi-square test, the correlation, and the regression analysis. These are the 4 main themes which we are going to go through one by one in this session. Okay. So let's move on to the next slide. Okay, so that was the agenda. I said so far this is the same thing that we have discussed in the first session, that we did the descriptive analysis. Why we do the descriptive analysis? To basically draw a generalization or to draw a hypothesis, some sort of that, and we can see what are the deviations or the outliers in the data. So after doing the descriptive analysis, we have basically the overview of the data. So after we have the overview of the data, then we are going to perform the inferential analysis. What does inferential analysis mean? It means we are going to draw the inferences about the data based on the statistical test we are going to do. Descriptive test only give the overview of the data, but in between differences or in between changes are not addressed in that. So for that, we are going to do the inferential statistics. After descriptive statistics, we can proceed with the inferential. So inferential statistics involve basically testing the hypothesis that we draw, or based on our descriptive analysis, we estimate some population parameters when compared to the general population. Or we use number of what we call number of parameters or number of values to compare that. That includes our significance level of the test, that includes p-values, that includes confidence interval, what is the effect size, that we are going to basically do in this workshop. Okay, so so the motive, today's goal is we have to what is the right statistical test and how we can interpret our outputs confidently. Okay, so what is hypothesis? So I usually define this hypothesis as any statement that can be falsified or testified. What does that mean? It means that the statement that is testable by statistical mean is called hypothesis. Usually there are a number of ways to classify the hypothesis, but in usual case at undergraduate level or postgraduate level, we keep to the two levels, that is null hypothesis and alternative hypothesis. Null hypothesis is usually denoted denoted by as H naught, while alternative hypothesis is denoted by H1 or H alpha A. So null hypothesis is usually that for any case or any scenario, null hypothesis is considered where there is no difference, there is no association. When there is a word of no association or no difference, it means that the hypothesis is null, or there is no significant difference or no mean difference. While in case of alternative, some sort of difference exists, some sort of relationship exists. So we usually construct two hypotheses. Okay, after constructing that two hypotheses, then we do the test statistics. Then we apply the statistical test. Okay, that could be t-test represented as t. That could be chi-square test represented as x, x power 2. That could be correlation. That could be ANOVA test from your sample. And from that statistical test, we compare with the help of what we have hypothesized. What are the decision rules? Decision rules are very much important here. We normally report our data. You have seen the research papers, number of multiple of research papers, okay, that shows the p-values. P-values like 0.02 or p-values like 0.05. And you have also seen some of the values that also can be, say, the alpha, the level of significance at which test, like 0.01, 0.05, and 0.1. These are the level of significance alpha. What does that mean? Any of you aware of what is level of significance can respond in chat. I want to see your answers. I want to see your concepts. What is level of significance? Can anyone tell? I want to see your answers in chat. Anyone? I'm receiving no response in the chat, so let me explain. That's basically how much you are confident. No, p-value is the probability, alpha is something else. I'm not talking about p-value. Okay, difference in data. Okay, some other answers I'm expecting. Okay. Okay, so alpha is the basically what you are saying, that is the margin of error you can accept it, kind of that. Like, see, you can accept, for example, you can there is a case somewhere in the court. Yeah, Dr. Sabah Heather has one of the given very brief answer. Threshold used to decide statistical result is considered significant or not. That is the correct answer, because this is a threshold, or this is the limit decides whether your statistical test is correct or not, and whether it's significant or not. When you post the alpha value, when you decide, and the alpha value is decided at the start of your statistical test, you can, whether you are giving 99% confidence or 0.1%, that is the strict threshold for statistically significant. You are not giving any chance. You are giving very rare chance of being falsified, or rare chance of being that. Okay, so these alpha values are decided in this initial when you have designed your hypothesis. Because there is margin of error to some extent. Yeah, error of value falling out of the confidence interval can be considered that. Okay. So moving on to the next slide. Okay, let me just. Okay, moving on to the next slide. Okay, so what we are going to go through, different tests. One is the t-test. Okay, there are multiple types of t-test. Okay, t-test, there can be independent t-test, there can be paired t-test. Independent sample t-test is called also two sample t-test, and it is also called as basically independent t-test is also called as unpaired sample t-test. Two sample t-test, unpaired, or basically independent sample t-test. So before we proceed on, keep in mind, yesterday we have discussed different type of variables. You have the discuss whether your data is continuous, whether your data is discrete, that is quantitative in nature, or whether your data is nominal. For t-test, you usually consider what we call your continuous data or discrete data that is quantitative in nature. Okay, and you should be aware that here we are going to deal with mostly independent variables, like we are going to show that what observation are independent based on the dependent. There are two types of variable, you know that from the very basis. There is independent variable and dependent variable. So here we are going to test the independent variable between the groups, that is classification. So if you are going through these tests, these are very much basic tests. These are for the continuous data, and the measure here we use is the mean. Here the measure in a t-test considered is mean, whether it's independent sample t-test or paired t-test. Paired is a condition, like for example, there is one study going on for the weight loss. Okay, so there is a program that says that we can proceed with the day, our program results in weight loss to the 30% of their body. So what we do at the start of the program, we take we are considering the 20 individuals. At the start of the program, we record their weight. Okay, and at the end of the program, after the 90 days, then we record their weight. Okay, so when the subject is same and we have gone through we are comparing that the results of that, then in that case we use paired samples t-test. Dependent variable must be interval for t-test if C mean difference in response to categories. Dependent variable is interval ratio. Yeah, it's interval. Yes, it's interval. Okay, so you can see that we are going to take some example. You have the data set. Okay, there is a research question: is the mean exam score different between online and on student campus? That is the one of the research question. They are comparing basically here two groups. In independent T cells, the parameter is one, but they are comparing two groups. Or we can say that we are comparing even, we can say the scores of one school or the scores of other school. Okay, so the subject in the independent samples may or may not be the same. But in case of paired t-test, the subject must be same. So this independent sample is between subjects. There are two independent groups, like see one on campus and online cohorts. If you would like to go through the SPSS, let me open the second data set that I have been shared earlier with you. Can you open your SPSS? So that I'm opening that also to show you the process of applying independent sample t-test between two groups. Okay, so let me go through that. You have the dataset 2, which I provided, the educational performance score. On the last day, you can download that data to apply this statistical test. The main purpose of the workshop is to apply in a software. Okay, let me share my screen with you. Okay, is my screen visible? The SPSS screen? Okay, let's open the data. Please keep your questions till end. Let's start with the import of data as we did on the last day. For example, for today, I'm using the dataset which are called dataset 2 student performance. Okay, I'm importing that dataset. Okay, Can you see the data set? Can you see the data set? Yes, okay. So let's see the data set. Here, there are different variables. We have seen the variable view, and I told you that we are going to use the Meyer or scale variable for most of the these statistical tests. For categorical, we use basically chi-square test. So how we are going to perform the independent t-test in this? Let me show you. You can go to this simple analysis and go to the compare means, and there is, you can see, if you can see, analyze, compare means, you can see you have different types of statistical tests for mean. That is one sample t-test, the other is independent sample t-test, okay, other is paired sample t-test, one-way ANOVA, and one sample proportions. These are the number of tests that can be performed in means, but the requirement for each test is different. So now we are going to perform the independent sample t-test, okay? For example, we are going to perform the independent sample t-test. You can see that is the interface, okay? Okay, now here I am going to see what is the difference between the gender. What is the difference between male and female score that they obtained in their final exam? So our test variable, we are considering it final score. Then we are comparing based on the gender. That is our grouping variable. You need to define this group as 1 and 2. After you defining, you can see, you can click options. You can keep confidence in interval 95%, which is alpha as 0.05. Okay, so after clicking that, you can change to 99 confidence interval. It will become 0.01, or if you can change into 0.1, that is 90% confidence interval. Okay, continue. You want to keep your test at 95% confidence. That is a usual thing. Everyone gives a 5% margin or threshold. Okay, let's click OK. Here is your output for independent sample t-test. Can you see the output generated? Can you see the output generated? Yes. Okay. So this is the output for t-test, and keep in mind, we need to know the significance. We always can what we call identify the significance with the help of our p-value that is here. Okay, what did we set the alpha or the confidence interval? I set the confidence interval in 95%. Is that right? Is that right? Okay, so the alpha will be 0.05, and this is the p-value. So your alpha is 0.05, and your obtained result is 0.404. Okay, or the 0. There are two conditions. I will explain these conditions too later, but this is the most important aspect. Okay, so you have obtained two p-values. One is 0.04, one is 0.408, right? Are they greater or smaller than alpha? Are they greater or smaller than alpha? Greater, smaller, greater. I'm seeing the variety of answers. Your alpha is 0.05. Okay, and you have obtained the p-value 0.404. It is greater. It's greater. When p-value is greater, we accept null hypothesis. We accept null hypothesis. Why we accept null hypothesis? Null hypothesis means there is no difference between the two groups. It means our conclusion for that will be that there is no difference in the final scores of male and female. Our test variable was the final scores between the two gender categories, male and female. Did you get my point? Did you apply your test in your SPSS? Did you get my point? Okay, so I think so that was clear. Okay, let's proceed with the another form of test, that is pair t-test. Okay, let's perform that pair t-test. Okay, so we will perform the pair t-test. Okay, so kindly explain the last point. I'm going to perform the pair t-test, then I'm going to explain the same point again, then you will understand. Okay, now we are going to perform where the subjects are same. In case of independent test, our subjects were two categories, whether it's male or female. But in case of paired, we are treating as one category. We are not going to genderize it. We are considering a class of students, okay, who got a who went a tutoring session, okay, kind of tutoring session. We are comparing whether their scores improved or not. We are going to compare their midterm score with the final score after they have gone to tutoring session. So let's do that. Okay, analyze in the same way. You are comparing basically means here. So we are going for paired sample t-test because we are considering there is no genderization right now. Okay, there is no genderization. Now we are considering as one subject, we are using their score before and we are using their score after. Let me raise these things so that the screen is quite visible to you. Okay, what is our hypothesis? Our hypothesis that there is no difference between the final and the midterm score after going through program. There is difference between the midterm and final score after going through the tutoring program. So this is our null and alternative hypothesis. Now we are going to apply the statistical test. What we are going to do? We are going to pair two variables. Now pair variables. Midterm score is our variable one. That was the previous score we recorded at the start. The final score. The subject in case are same. There is no categorization of group. Okay, you have options. You can set your confidence interval to 95%, you can set to 99%, or you can set to 90%. 95% confidence interval means it is 0.05 alpha. 99 confidence interval means, what does it mean? 0.01% alpha. What does 90% confidence interval mean? What will be your alpha at 90% confidence interval? Can you write in the chat? What will be the alpha at 90%? No, some people said 0.01. No, that's 99. It would be 0.1. Those who wrote 0.1 or 0.10, that are correct. Okay, so let's continue. I'm going to run the test. And here is our output. Can you see the output? Can you see the output? Yes. So what we call p-value here? Can you write the p-value from the output? Can you write the p-value from the output? Can you point out the p-value? No, that's not the p-value. 1.75 is not the p-value. Less than 0.001. Yes, that's the p-value. Yes, that's what is your alpha for this statistics? We set 95% confidence interval, right? The alpha value was 0.05, right? Now the p-value is 0.001, right? Yes. Now the p-value is less than 0.05, right? It is less or greater? Your p-value is less than alpha or greater than alpha? Okay. In this case, what will you do with your null hypothesis? You will accept or reject? You will accept or reject? No, reject. you will reject. When the p-value, obtained p-value is less than your alpha, we will reject null hypothesis. So we will reject. Our hypothesis was there is no significant difference between the score of midterm and final term after going through tutoring program. We will reject the null hypothesis. It means tutoring program has some impact, right? Tutoring program has some impact, right or not? Okay. I said except the alternative one. Okay, there is one thing, let me clarify you. As we are going to the statistical SPSS workshop, we normally say we have sufficient evidence to reject the null hypothesis. Okay, we have sufficient evidence to reject the null hypothesis, or we accept the null hypothesis. We will never write that we accept the alternative hypothesis. We will always quote in terms of our null hypothesis. Okay, we won't say straightforward that we accept alternative hypothesis, because that's the reason there is a chance that it can be true or it can be false. So here the concepts of type 1 and type 2 error lie. Okay, so we reject the null hypothesis in this scenario. Okay, and we can conclude from that, there is a significant impact of the tutoring on the scores of the student. Is that right? Is my conclusion right? Is my conclusion right? Yes. Thank you so much. Some of the students are responding really well, and I'm happy about that. Okay, right. So we will move to the next test. So far, we have discussed independent sample t-test and the paired t-test. Now, we are going to move towards the chi-square test, okay, where we are going to deal with the categorical data. We are going to deal with the categorical data. When your data is in categories format, okay. Okay, what does chi-square test do? Have you any idea? Do you have any idea? Please. If you have any idea, you can post in chat. Let me open the presentation.
chi-square test.
Yes.
Hello.
Yes, I am.
सर chi-square test जो है ना वो पॉजिटिव स्क्यू कर्व के लिए यूज होता है.
किस चीज के लिए यूज होता
हम
है?
यूज करते हैं पॉजिटिव स्क्यू कर्व के लिए. जो डेटा होता है ना वो जब वो पॉजिटिव स्क्यू होता है तब यूज करते हैं. एक जेड जो होता है वो नॉर्मल डिस्ट्रीब्यूशन के लिए यूज करते हैं, और chi-square जब डेटा एबनॉर्मल हो मतलब पॉजिटिव स्क्यू हो तब यूज करते हैं.
ओके, स्क्यूनेस तो नॉर्मली जो आप बात कर रहे हैं वो है नॉन नॉर्मल डिस्ट्रीब्यूशन. ठीक है, आप बात कर रहे हैं कि भाई नॉन नॉर्मल डिस्ट्रीब्यूशन होगी तो हम पैरामीट्रिक टेस्ट अप्लाई करेंगे. ओके
यस सर, मतलब chi-square टेस्ट अप्लाई करेंगे.
ओके, बट फॉर द स्ट्रेट फॉरवर्ड रूल आई विल लेट यू नो दैट कि chi-square टेस्ट के लिए पहले क्लासिफाई करना ये जरूरी नहीं है कि नॉर्मल डिस्ट्रीब्यूशन है या नहीं है. हम नॉर्मल डिस्ट्रीब्यूशन ड्रॉ करते हैं कंटिन्यूअस डाटा के लिए. हम नॉर्मल डिस्ट्रीब्यूशन
नो सर, मतलब यही होता है ना नॉर्मल डिस्ट्रीब्यूशन में जो है ना जेड एडेड यूज करते हैं.
Okay, let me category value. Okay, we normally construct.
सर ये नॉर्मल डेटा होता है क्या है?
अभी आप स्क्यूनेस की बात कर रहे हैं.
नॉर्मल डेटा होता है क्या है?
नॉर्मल डेटा वो होता है जो एक है जब उसका हिस्टोग्राम ड्रॉ करें, when we draw the histogram, okay, and the histogram appears to be the bell shaped. Okay, the histograms appear to be bell shaped, and we have discussed these things in the last lesson. So for last day of the workshop. Now here we are discussing about the chi-square test. Okay. Okay, please turn off your mic. If you have any comments, we will take at the end. Let me go through because everyone is here. Okay. Okay. Dr. Sabha has yes.
सर एक कंफ्यूज है लेकिन सर जी सर मैं कंफ्यूज हूँ, दोबारा समझा सकते हैं?
बच्चे, let me explain. Let me start. I will explain very well. Just give me a space. Okay. Okay. We are going through the chi-square test. Okay, and the chi-square test is basically used for the categorical data. The person Izzat was saying that when we have non-normal distribution, and I am going to pinpoint that at the end of some slide. I have that point in my mind, and I will address that why we can't use the continuous data for the chi-square test. First of all, the criteria for chi-square test is your variable must be categorical. If your variables are not categorical, it doesn't matter, you can't apply chi-square. Okay, you can't apply chi-square. What does categorical means? They have categories like gender, male, female, color, black, blue, red. Okay, cars names, what we call Sportage, Alto, or some sort of. So there must be specific categories for the chi-square test. When you have specific categories, then you can apply. Okay, chi-square test. And
Sir जी, excuse me sir.
yes,
Excuse me sir.
yes, please.
Sir ये categorical data होता क्या है?
I am just telling you that those that have categories, okay, like the car names, these are categories. Like the colors, these are categories. The one which the variables that can form categories is called categorical variable. Okay, and it can be also called nominal, and we can have also the ordinal data. Okay, please, turn on your mic. You can post any question in the chat, and you can ask as many questions as possible at the end, not in between the session. You can note down your questions. Okay, what is categorical variable? That has categories, and that categories, number two, that categories are countable. Okay, we do not calculate means for that. Means we calculate for the numerical data. Okay, I said before before the start of the first day, I told you about that we have in the variable pane. I have told you that there are what we call okay, thank you. Okay, so we have categories. Okay, and the first point is the categories. Okay, there must be two categorical variables, not one, two category variables. Is that, please mute your mic.
Excuse me sir, एक confusion है.
जी बच्चे इज्जत, what's your confusion? You can just post your question in the chat. You are not allowed to speak right now. Let me proceed because the whole workshop is halted. You can just post your query in the chat. Okay. Okay. Chi-square test. For chi-square test, it must be categorical variables. Number two, the data must be represented in contingency table format. There must be rows, there must be column. Okay, the data can be categorized into rows and columns, and the variables must be normal. And there's one most important thing about the chi-square test is that each cell in your contingency table must be greater than 5. Each value in the contingency table must be equal to 5. Okay, and this chi-square test, distribution test, basically checks the relationship between two variables that are categorical in nature. Okay, and we report them also as the p-value and the chi-square value. Okay, we report as the p-value and the chi-square value. Moving on to the next slide. Okay, I told you core assumptions. Okay, each cell has to be the number should be greater than 5. Okay, this is the condition. These are the core assumption. Data must be countable. Use raw frequencies, not percentages or means. Means and percentages, any type of descriptive analysis is not allowed. Here the frequencies are considered. When we do the descriptive analysis, there are frequencies we considered. Okay, number one, and the large sample is as much large sample as much the results are your accurate. Okay, okay. When, for example, if you are in your columns and rows, when your values are less than 5 in case of contingency table, then we use Fisher exact test. Okay, let me show you before proceeding further. Let me show you how to perform the chi-square test in SPSS. Okay. Let's proceed with the same data set. You will have the data set. So let's open the data set. Okay. Can you see my data set? No? Yes, okay. Yes. Okay. Can you name some categorical variables here? Can you name some categorical variables here? There are a number of categorical variables. Can you name some of them? Study program, yes. Study program, okay. Gender, okay. Gender, age is not a categorical variable here. Age is in numbers. By the tutoring, midterm score is not a categorical variable. Categorical variable has to be basically categories. And if you see the SPSS, it's quite visible which are the categorical variables. Gender has categories, study program has categories. Those who have drawn scale are not categorical variables. These are not. These are not. This is categorical. This is internet access, parent education. These are not. You can see that they are coded as 012, 012, 012, 012. These are. Okay. These are 1, 2, 3, 4. Other has numbers. Has decimal numbers and their scores are something different. These are not categorical variables. Categorical variables has, yes, parent education is the categorical variable. Okay. Yes, the circle ones are the categorical variables. Okay, now let's take the two category variables. For example, we are going to check whether there is how many students are enrolled in some tutoring program based on their gender. Is there any relationship between the enrollment in the tutoring program based on their gender? Let's check their relationship through chi-square test. What we will do here? Okay, let's analyze. Okay, click analyze. You will go to descriptive statistics. Here you have the cross tabs. Can you see that? Are you able to see that? Yes. Okay. What variables we have studied for this question? We have selected gender. We will place one category variable as row, and the other program we have selected the tutoring. Okay, we are checking whether there is any relationship between gender and tutoring or not. Okay, now you will click on the statistics. You will take here the chi-square. Okay, you will take on the chi-square and you will plus continue. Okay, and these are your results. Can you see the output? Can you see the output? I'm waiting for your responses. Before we discuss the output, I'm waiting for your responses. Okay, you are not able to see the output. Okay, let me see. Now, can you see the output? Yes. Let me run again, because if some of have missed them, they can see again. Descriptives, then we will go to the cross tabs. Okay, we have selected gender, we have selected tutoring, we will click statistics, we will click the chi-square. Okay, and then we will continue and press OK. Okay, can you see the output generated now? Yeah. Okay. Okay. So we have obtained the chi-square value here. Okay, this is the chi-square value. This is 0.007, and this is, we have the p-value. This p-value is 0.936, right? The p-value is 0.936. What is our alpha? What is our alpha? We're not stated about, 0.05. So in this case, p-value is greater or smaller? P-value is greater. Yes. Now, what you will do? You will accept or reject? Oh, think again. You will accept the null hypothesis. When p-value is greater, you will accept the null hypothesis and you will conclude that there is no relationship. There is no relationship between the gender and the tutoring. Yeah, there is no relationship. So far, this is the simple chi-square test. Okay, there is one thing you note. One thing you should note here before reading to. Yeah, there is no significant association. Yes, thank you. Okay, so there is one thing you must know here. You can see that there is no value here less than 5. Right? In your contingency table, you can see that there is no value less than 5. Okay, so as you see, there is no value less than 5. Then we will take the Pearson chi-square test. If there is less than 5, then we will consider the p-value of Fisher exact test. Then we will consider the value of Fisher exact test. Is my point clear? In what cases you are going to consider the chi-square test, the Pearson chi-square value, and in what cases you are going to consider the p-value of Fisher exact test? Okay. So I think so far you are clear about your this chi-square test and how we are going to perform this chi-square test. Okay. So we should move forward. If you have any question up till now, you can ask me relevant to these two tests. Or should I proceed? Okay, proceed. Okay, let's proceed. So far we are clear on that. Thank you. Thank you for your response. Now I'm going to share the presentation again. Okay. So can you see the screen of presentation? Okay. Let me raise these things. It will create some sort of confusion. Okay. These are the I have discussed so far what we are going to show the significant variable. Okay. Now you can see here in this one, you can see that the p-value is less than your alpha. So it's significant association. So the two variables are associated. Okay. Okay. I think that is pretty much clear. Yes. Okay. Moving on to the okay, in the slides, I have done something for you. You can do it. You can review after the workshop that I have attached the reporting format for APA style that you can review later. Here we are short of time. We have to cover 2 to 3 more tests before we proceed. Now we should proceed further. Okay, let's proceed further. Okay, now we are going to do the correlation. We are talking about correlation. We have performed the chi-square test. Now we are seeing correlation analysis. Correlation analysis done whether you have your continuous data, whether you have your categorical data, you can do the correlation analysis. You can check whether there is relationship between two variables or not, whether there is some sort of relationship. So in correlation analysis, keep in mind, there are 2 types of correlation analysis. One is this Pearson, okay, other is a Spearman. Okay, what is the range of this correlation value? You predict your correlation values, whether it's strong or it's negative or positive, whether it's strong or weak. When your value is 1, it means it is strong. But if it has attached minus sign, it means a negative strong. Okay, we can basically interpret it based on these values. For example, if you have minus 0.98, what will be your interpretation? It is strong but negative strong. Okay. Okay, if it's minus 0.02, it's weak negative. What it's if 0? What will be, what you will consider 0? What does 0 mean? No relationship. Yeah, exactly, no relationship. If it is positive, okay, if it is positive 1, it is strong positive. It is minus plus 7, plus 0.07, then it is also a moderate positive relationship, and that we can represent in graph. Okay, there is one value I am going to quote. Whether tell me if it is correct or not, and what should be the relationship. If it's minus 1.9, if there is correlation analysis, we perform the correlation. It cannot be. Yes, it cannot be, because your range is -1 to positive 1, and the strength is defined by the value. Yes, that's impossible. Okay, direction, basically science shows the direction. One, keep in mind, correlation doesn't mean there is causation. Correlation doesn't mean if there is correlation. Yes, your values for the correlation range from -1 to +1. So how we are going to perform this correlation analysis? Keep in mind, for ordinal data and for non-skewed data. For example, we have discussed that your data, if a shape, the bell shape curve, it follows the normal distribution. Okay, if follows the normal distribution. If the data is somehow skewed to the left, to the right, we have discussed in the last session, then that is non-normal data. If your continued data is not normal, or it is ordinal or categorical, then you will use Spearman. If your data is Pearson, your data is basically normal and continuous, then you will use Pearson value. Is that clear? Is that clear? Yes. Let's move to the performance of this Pearson correlation to see how our graphs and everything looks like, how our results and outputs look like. Let's move to the SPSS. Can you see the data set? Yes. Okay. Okay. So we can see the data set, and now let's do some correlation analysis. First of all, we will select any two variables to check the relationship. Okay, these are we can use what is the study hours and the study hours and the midterm score relationship is. So we could do the simple relationship test between them. Okay, what we will do, you will go to the analyze. Okay, you will go to the analyze, you will correlate, you will be using bivariate. So what are the two variables we are selecting here? We are study hour weeks. Okay, and then next we are going to the midterm score. You should also click the Spearman, it will give you an idea. Okay, let's can you see the output? Can you see the output? Yes, the output. Okay, this non-parametric correlation is for Spearman. When we have non-normal data, then we will proceed with the Spearman. If we have normal data, these two variables are normal, study hours per week and midterm score. What we can do, we can simply construct their graphs to see whether they are normal or not normal. Okay, let's build a chart, then we proceed with better interpretation. For this, we usually why do you suggest why do you select Spearman at this stage? Okay, to just give an overview, but let's see if we should need or not. Okay, let's draw a histogram. It's better to see that. Let's do a histogram, then we see that. Okay, there is a histogram. What were our variables of study hour? Study hours. Okay, is study hour normally distributed? Can you see the output? Yes. Okay, now our next variable of study was for the graph purpose. Next, our reset histogram, then select again. Next, our second variable was our midterm score, right? Okay. Is that normally distributed? It looks like somehow normal. Okay, it attains the bell-shaped curve. Yes, somehow. Yes, when both variables are normally distributed, they are not skewed, we will only go for Pearson. Sabha, this is answer to your question, Dr. Sabha. This is answer to your question. Yes, we should select after what we call seeing the graphs. So if both the variables have normally distributed, we will simply go for what we call Pearson correlation. Let's go back to that parametric test. We will interpret this. Okay. Now see what is the p-value and what is the correlation. Our correlation value is, what is our correlation value? Can you write down in chat? Can you write down in chat what is our correlation value? No, I'm talking about correlation value. No, incorrect, incorrect. 1 is not the correlation value. Okay, let me guide you. Most of them are wrong. Okay, what we are doing in the correlation, we are comparing the two variables. Here, those who are saying 1, they are saying the same thing, steady R's and steady R's. We are not checking the relationship between the same variable. Our correlation value is between midterm score and the steady of R's, that is 0.360. And as minus sign is not there, it will be considered as positive. Okay. Same is the case when we are going to compare midterm with the steady as in the same way it is shown plus 0.360, right? Right? Is that clear now? Yes. Okay. Now, what should be the interpretation? It's a strong positive, strong negative, weak positive, weak negative. What is your interpretation about this correlation? What is the relationship between? Okay, strong positive, weak positive relationship, weak positive. Okay, weak positive. It's weak positive because the value is much less than 1. It's even less than 0.5. 0.5 or 0.6. We consider it somehow moderate. It's weak positive, and we can see this with the help of graph even. Okay, we can see this with the help of graph even. Graph chart builder. Okay, correlation analysis. We can reset it. We can set at a scatter and dot plot. So we have one at the one angle steady R's, the other angle midterm score. Okay, we can see the graph and see this. The values of the data are spread. If you draw a line of best fit, it won't be all the points won't be on line. If I draw for you simply like that, it won't all be on the line. We cannot construct a line. So points are deviated. It's weak positive. Is that clear up till now? Yes. So let's move further. Now, there is one thing I want to let you know. I want to tell you before we proceed further. Okay, let's come here back to our correlation results. Okay, now you see the p-value. Now you see the p-value. Okay, what is your p-value now? Here. Yes, the p-value is, no, it's not 0.01. It's 0.001, right? It's 0.001. It's statistically significant or not? Statistically, it's significant. So it's good that most of people are getting it point. And this is statistically significant at even 0.01 level. If we take alpha, yeah, highly significant. We can say that highly significant. Yes. If we take at the 99% confidence level, we are good to go with these results. Okay. Is there, up till now, is everything clear? Okay, let's move further. Okay, can you see the PPT now? I have discussed this in detail, so I'm not going to discuss through slides because we have generated. You can see this scatter plot even. Okay, we have constructed this scatter plot even reporting style. Okay, next is the topic is our regression. Okay, what is our next topic? Regression. First of all, we did the t-test. Okay, next we did the chi-square test. Then we did the correlation analysis. Okay, sir, if the value is minus 1.2 in correlation, more than minus 1, repeat this point. No, value cannot be minus 1.2 in correlation. Okay, value cannot be minus 1.2 in correlation. Okay, your correlation value will always range from minus 1 to 1, positive 1. Okay, might be you have missed where some point, that's why you're saying that correlation value cannot be less than minus 1 and not greater than plus 1. Okay, okay, next we are going towards our regression concepts and equation. So regression is one of the vast study topic of statistics, and that is being widely used in number of research for the research purposes. Okay, whether it's biological science or whether it's natural science. So the regression is used most of the time. So there are different types of regression. The simple regression, where we discuss the effect of one variable on the other variable. You know that we can classify our variables as dependent variable and the independent variable. Okay, then we have the multiple regression, where we have multiple independent variable affecting the dependent variable. Then we have multinomial, where we have the nominal type of variable. Okay, we have logistic regression analysis, we have multiple regression analysis. There are a lot of basically regression models that we use. Okay, so you can see that the simple regression is equal to y is equal to a plus b x into epsilon or epsilon. Basically that equation most of the time you might have mx plus c. You can have you have been viewing that as that equation. Okay, so let's see how we can perform regression analysis in our stat. First of all, we must know what are our dependent variables, what are our independent variables. Okay, okay, is that clear? Is that clear? Yes. Okay, we must know what our dependent variable, what our independent variable. Looking at the data, let me open the statistical data. If you see that, can you suggest some dependent variable and independent variable? Can you suggest some dependent variable or independent variable? Study are dependent. Okay. Okay, attendance is independent variable and final score is dependent variable. Okay, study R cannot be dependent. Think again. Can you control study R of a student? So we cannot control that variable. So study R is independent variable. How much each student study is independent variable. Study R is independent variable. What will be the effect on that score? Score will be our dependent or independent? If we consider midterm score or final score, it will be independent. So let's apply the regression. Okay. Yeah. Okay. Okay. Let's apply the regression. Analyze, and here I want to show you something. Analyze, and then you can see different types of regressions. Can you see? Binary logistic, multi-logistic. I have clicked the oh, someone else? What happened? Someone else has screened the shade. Whoever is sharing screen, please close that screen. Let me stop share and start again. Who is sharing the screen? Okay, let me share again. Okay, now it's okay. Let me share again my screen. Now can you see that? Can you see the SPSS? Okay, now let's okay. Let's see that. Okay, now you can see the regression. Okay, you can see binary logistic, multi-inoculation, ordinal. These are different types of linear curve estimation. These are different types of regression. Here we are going to apply the linear regression. Okay, what is your dependent variable? What is your dependent variable? The final score. We are talking about the score. The final score. What will be your independent variable? Study hours a week. Study hour a week. Okay. Now, what you want as a statistics? You want to set as a 95 confidence interval. You need all the estimate. You need also descriptive analysis. Usually, you can check that. Okay. So, can you see the output now? Yes. You have seen that we have the correlation results. Now we have the R score, we have the regression results, and the main thing is this. Can you see the significance level? Can you see the coefficients? Yes. These are the basically output. Let me open the PPT and then you see that output, annotated output, that gender cannot be a dependent variable. Gender cannot be a dependent variable. Why? Can you control the gender? We can't control the gender. Gender cannot be an independent variable. Okay. Let me share you the annotated output for the regression, and then we see how much you understand that. Okay, simple regression model. Okay. Can you see the R square value? You have in their SPSS. Here you have the R square value. It explains. What does it explain? Can someone tell? That explains the variance. How much the dependent variable affect the dependent variable. What was our study question? Can you write the study question in chat? What was our study question? Our study question was to check the effect of study hours. Yeah, IV impact on the DV impact positively. Okay, that was our, so this shows that 22.1% is 21.2%. The independent variable has the impact on the dependent variable. What was our independent variable? Our independent variable was study hours. Study hours has 22.1% effect on the dependent variable. Yes, it is causation. While you know that in correlation, we said there is no causation. We just check whether there is a relationship or not. But this tells actually how much this variable is affecting that. Okay? Did you get my point? Okay. So this is how you can perform different type of regressions. Okay, different types of regressions. Now you can see the simple ANOVA output in your also SPSS. You can, in the same way, can interpret whether this model is significant or not. Okay, whether this model is significant or not. Now your p-value is 0.001. What does that mean? Our model is significant or not? Highly significant. Yes, exactly, the highly significant. Okay. So this is how we perform the regression analysis in that. And now the main aspect is the equation. Okay. This is the error, or the epsilon and sign shows this is the error, or this is the residual effect that cannot that are at random, that we cannot control in our model. And every model has that value. Okay, has that value. Now please focus these to what we call, I want to see that can you construct equation from your output? Okay, what is the intercept, what is the standardized B, what is the unstandardized B? Okay, how to generate equation for the conceptual model? Yes, I am going on that point. So coefficients and interpretation, I am going on that point. Can someone write equation for our this model? 1 second. For equation, we will use this. So can someone write equation based on that? I'm waiting for some of your answers. We have our equation. If you keep that in mind, equation. I'm waiting for answers. No one has written. Okay. You're waiting for me to answer. Okay. First of all, these are the two most important values for writing an equation. Okay. What is your y? Y is your independent or dependent variable? Y is your independent or dependent variable? What is your y? Dependent. Okay. Okay, let me write let me write equation for you to make it easier. Your general equation, what is y is equal to a plus bx, right? So y and x, you will get your these values. Based on this, you will get basically this b is your slope, a is your intercept. B is your slope and a is your intercept. Okay, so what's your intercept? Intercept is this one, the constant one, 52.790. Okay, and what is your slope? Slope is what is the slope? Plus 0.643, 0.953. 3. So your equation will be y, okay, y is equal to 52.790 plus 0.75x. Okay, can you see that equation now? This is your intercept. What is intercept? Okay, this is your intercept. What is intercept? First of all, define yourself. What is intercept? What is in? Let me show you in the slides to be easy. Most of them are not getting what point, they are asking for repeat. Okay, let me show you in simple way. Okay. This is your simple linear regression. Okay, you have constants. Okay, the constant is always listen. Okay, listen. The constant is always your intercept. This is your intercept in any equation. This is your intercept, and the rest of them will act as a slope. Rest of them will act as a slope. Okay, so your equation is y is equal to your equation is intercept a plus b into x. A is constant, that is intercept. Okay, that is intercept 12.325. B is the slope, the variable you are considering, the association between them. Okay, a plus bx, yes, right. Okay, you are asking Dr. Sabha, either you are asking why constant is intercept. Intercept basically is defined when the one value is 0, the other shows the value. It means that, let me show you. Okay, this is the main slide which I want to show you. This is the main equation I want to show you. Can you see? Annotate. Yes. Can you see that this is the intercept? Okay. What does intercept mean? It means is when the value of y when x is 0. Okay. You usually represent x in the graph here. Okay, and y here. Okay, so when the value of x is 0 and the value that touches, that is called intercept. Okay, the other is slope. Okay, it means each 1 hour study increases score by 2.4 hours. Okay, so then you can see that this is our equation. This is how much we can okay, now you get to the point. Okay, now if for example, we have the equation and I say you that please, if a person studies 5 hours, okay, if a person studies 5 hours, how much will be his predicted score? We are doing the prediction. So we will simply add 5 here and calculate, and we will have the predicted score. Here, regressions are used to predict. Okay, regressions output are used to predict. Okay, and then it is whether that prediction is how much is going to be accurate. It depends on, again, your p-value, and the p-value here is statistically significant. as it is less than 0.05, right? Okay, now you can see that. Okay, p-value of the model, yes, it's the p-value of the model. Here in the output of the, when we are writing the output from the equation, there is shown the p-value, and that is the basically p-value of the model. You can see that here in this annotate. Let me raise this. That here the p-value of the model is. Can you write the p-value of the model in chat? This is the p-value of the model. This is the p-value of the model. Yes, this is statistically significant. Statistically significant. Okay, there is one more thing I want to tell you. One other way to define your whether model is significant or not. That is based on the confidence intervals. That is based on the confidence interval. If the confidence interval contains the value of 0, if the confidence interval contains the value of 0, it means your model is not significant. In this case, yes, the both values for the confidence interval might be positive or negative. If it contains the 0 value, then it's not significant. In this case, can you say whether the model is significant or not based on the confidence interval? Yes, significant. It's clearly significant as it does not contain 0. It does not contain the value of 0. So these were some of the models and some of the tests which I was supposed to demonstrate. Significant does not contain 0. Yes, you can say that significant does not contain. These were some of the tests which I wanted to show you in this workshop, and the PPT will be shared. You can practice the exercise, and there are much more details which cannot be covered in that short duration. But if you have any questions, you can email me anytime. I will respond it. You can use these slides as a reference for your learning. I hope I have tried my best to demonstrate you, and I will hand over the session to Javeria Bahadur. He will conclude the session. She will conclude the session. And I hope so you liked the learning process. Thank you. Thank you. Much appreciated. Much appreciated. Javeria, please. You will have the feedback form. Okay.
Thank you, sir. All right, before we officially wrap things up, just a quick couple of updates so no one feels lost later. Yes, the session has been recorded and we will be sharing the recording with you, so you can revisit the concepts at your own pace. And once we share the feedback form, please note that it will remain open for 30 minutes only, after which we will be closing it. Now, moving on the more important part, and it's gratitude. First and foremost, a huge thank you to our trainer, Sir Wahid Ahmed. Sir, over these 2 days, you have taken us from absolute basics to confidently running and interpreting analysis. The way you simplified concepts, connected them to real research, and guided everyone step by step truly made this workshop impactful. We are really grateful for your time, efforts, and energy. And of course, thank you to all the participants. Staying consistent over the 2 days, engaging in hands-on workshop and actively learning, that takes commitment. And I would like to take a special moment to thank our international participants who joined us from different parts of the world. Your presence truly added a global flavor to this workshop, and despite time differences and busy schedules, you chose to be here with us, and that means a lot. This kind of international participation is exactly what RSU Pakistan and ISCB Student Council stand for, learning beyond the borders. And for those who may not have heard this earlier, I am your host, Javeria Bahadur, and I have been hosting today on behalf of my team, RSU Pakistan. And it's been an absolute pleasure being part of this journey with you all. Now, just to clearly and calmly walk you through the certificate process, so there is no confusion later. Certificates will be issued to registered participants who attended today's session, and those who will complete the integrated form I am going to share in the chat box. And this form includes a short quiz, not for grading or judging anyone. It is simply to help us assess learning outcomes along with a feedback session so we can keep improving future workshops. And one important thing to remember, the form will be shared only in the live session chat, not in the WhatsApp group, and it will be available for 30 minutes only. So please stay attentive and submit it within the given time. And now I want to say that behind every smooth workshop or event, there is always a team, and that team works quietly in the background, and this one is no exception. And a heartfelt shout out to the RSG Pakistan team for making this workshop happen. Special appreciation to our president Hasib Manzoor, to our outreach team lead Samir Rahman, and graphics team lead Taiba Osman, and all our other teams, content team. And for those who are new to us, just a quick note. RSG Pakistan is a regional student group under the ISCB, International Society for Computational Biology Student Council. We regularly organize workshops, talks, and training sessions like this to make skill-based learning accessible, practical, and student-friendly. And yes, this won't be our last event, so stay connected. And there is more coming your way. Before we close, just a small reminder. Learning doesn't end when the session ends. Take your time with the recordings, practice on your own data sets, and most importantly, keep asking questions. That is how real learning happens. And once again, thank you to our trainer, Sarvahit, and thank you to every participants, and thank you to the entire RSG Pakistan team. Wishing you all the very best in your research journeys, and we hope to see you again very soon in another RSG Pakistan event. Thank you.